So today we're going to look at adding, subtracting, multiplying, and dividing algebraic fractions. So to get started, we're going to multiply fractions first. When we multiply fractions, we multiply straight across the top and straight across the bottom. Anytime you have two terms with algebraic fractions, you're going to put parentheses around them, separated by plus and minus signs. So when we multiply straight across the top here, this quantity times 1 is just the x squared minus y squared. Along the bottom, you have your x minus y, that quantity squared, times your x plus y. Our next step, once we multiply straight across the top and straight across the bottom, is to look to see if you can factor the numerators or denominators. This numerator right here, two terms, can't pull out anything. It's separated by a minus sign. It looks like a difference of squares. Difference of squares factors into two parentheses, x plus y, x minus y. Denominator here, x minus y, there's no GCF. It's not a difference of squares or cubes, therefore it's not factorable. The second parentheses separated by a plus sign, so you're looking if it's a sum of cubes. They're not cubes, not factorable. So the denominator is left alone. Once you have everything factored, you look in the numerator and denominator, see if there's anything that you can reduce. We have a common factor of x plus y on top and bottom. We have a common factor of x minus y. You're only canceling out one of the x minus y's in the denominator, so you still have an x minus y in the denominator left. However, everything in the numerator canceled out. When everything cancels, you must leave a 1 in its spot. Okay, so you're going to notice my numbers jumped here. That's because we are, again, following a handout. So on number 3, we have a fraction times a fraction. When you multiply fractions, you multiply straight across the top, straight across the bottom. We have more than one term in the numerators and denominators, so we're going to put parentheses around them to multiply straight across the numerator, straight across the denominator. So rewriting it looks like that. Okay, at this point we're ready to factor. You look in each of these parentheses, see if you can factor. Here we have 3 terms. No GCF, can't pull out a GCF, so we set up reverse FOIL. X times x is x squared. We're looking what numbers multiply together to give us negative 35, that combine together to give us negative 2. That's a negative 7 and a positive 5. In the next parentheses, we look to see can we pull something out. There is a common factor of an x. So we're going to pull out the x, and we're left with 4x squared minus 9. We're not done factoring that one. We'll come back to that here in just a minute. Let's go ahead and jump down here to the denominator. Notice there's an x squared that we can take out of both of those, GCF. And then when we take out the x squared, we're left with 2x minus 3. In the second parentheses in this denominator, you'll notice we have a 7. That's a GCF that we can pull out. When we pull out the 7, we're left with x minus 7. Let's check those parentheses, make sure we can't factor them further. Here's a minus sign. It's not a difference of squares or cubes. This is a plus. It's not a sum of cubes. Here's a minus. It is a difference of squares. X is something squared. 2 squared is 4. 9 is 3 squared. So we can factor that. We've pulled out the x. Difference of squares, you set up 2 parentheses. This time we have 2x times 2x to give us the 4x squared. 3 and 3 make the 9. Difference of squares, we have to have plus and minus. In the denominator, the 2x minus 3, the difference, it's not of squares or cubes, so you can't factor it. Here it's a difference, not of squares or cubes, it's also not factorable, so we're leaving the denominator alone. Once you are sure that you have everything factored, notice we can't factor the 2x plus 3 or the 2x minus 3 because they're not sums of cubes or difference of squares or cubes. We look to see if there's anything that will reduce in the numerator and denominator. So the x minus 7 cancels out. The 2x minus 3 will reduce. And we have an x here that will reduce with one of these x's. So we're left with x plus 5 2x plus 3 in the numerator, and then the 7 and x in the denominator. Notice it's okay to leave this in factored form. If you are asked to put it in simplest form, you would have to multiply out these parentheses by foiling. I am not going to ask you to FOIL that out. Let's go ahead and move on to example 5. So again, we're multiplying two fractions. You multiply straight across the top, straight across the bottom. If you want to, just to make one big fraction, make sure you put your parentheses around your numerators and your denominators. That would save you a little bit of space on your paper. Okay, so we're getting this all set up, and now we're ready to factor. Notice three terms here, can't pull out anything. So then we set up our reverse FOIL, our two parentheses. A times a is a squared. We're looking for two numbers that multiply together to give us -6, that combine together to give us a -1. So that gives us a -3 and a +2. On the second one here, three terms, can't pull out a GCF, so set up our reverse FOIL, two parentheses, a times a is a squared. We're looking what numbers multiply together to give us -8, that combine together to give us -2. That's -4 and +2. Looking at the denominator, three terms, can't pull out a GCF, so set up our reverse FOIL, a times a is a squared. What numbers multiply together to give you 12, that combine together to give you -7, that's -3 and -4. Second parentheses in the denominator, three terms, can't pull out anything, set up your reverse FOIL, two parentheses, a times a is a squared. We're looking to see what numbers multiply together to give us -10, that combine together to give us -3. That's -5 and +2. Alright, everything's factored. We look to see if we can factor anything further. At a quick glance, you'll notice your A's don't have squareds or cubes, and there's always all two terms in there, so we can't factor any further. Our next step is to reduce. We've got an a -3 in the numerator and denominator. We have an a +2 in the numerator and denominator. We have an a -4 in the numerator and denominator. All we're left with is a +2 in the numerator and a -5 in the denominator. You are not allowed to cancel these a's. There is one on top and bottom. However, that plus sign and that minus sign are gluing those two terms together. The only way you're allowed to cancel is if you cancel the entire term, a +2, off with an a +2 in the denominator. You are not allowed to cancel with addition and subtraction in the middle, only with multiplication. Alright, let's move on to the next example. The next example is taking us into division. We never divide fractions, we always change division into multiplication. So to change from division to multiplication, we use the little saying keep, change, flip. We keep the first fraction the way it is, we change the division symbol into multiplication, and we flip the second fraction over. Keep, change, flip. So looking at our algebraic fraction here, we're going to keep, change, flip. We're going to keep that first fraction, we're going to change that sign to multiplication, we're going to flip that second fraction over. Once we do that, we are ready to multiply. We just learned how to multiply. We're going to make this into one big fraction. Make sure you put parentheses around the terms that had plus and minus signs in there. It's kind of like super glue, it's gluing those terms together. Once you do that, then you look to see if you can do any factoring. So this m squared minus n squared, there's no GCF, but it is a difference of squares. Difference of squares can be factored. So we're going to go m times m is m squared, n times n is n squared, difference of square signs, plus and minus. R plus s, two terms separated by a plus sign, there's no GCF. It's not a sum of cubes, therefore you can't factor it. Alright, so we did already check the R plus s. The m minus n, two terms separated by a minus sign, you can't pull out a GCF, and it's not a difference of squares or cubes, therefore can't factor it. So now, once you have everything factored, you look on top and bottom, see if there's anything you can reduce. We have an m minus n that cancels, an r plus s that cancels. All you're left with is the m plus n in the numerator. Now technically it's over 1. You don't have to write a fraction over 1. Also, if everything cancels in the numerator and everything cancels in the denominator, your answer equals 1. It is not no solution or simplified, okay? So if everything cancels, your answer is 1. Okay, looking at the next example, it's another division example. So again, we're going to keep, change, flip. Once we do our keep, change, flip, then we see if we can do any factoring. So looking at the numerator here, c cubed plus 8. Can't pull anything out. And so if you can't pull anything out, you look to see if you have a sum of cubes. C is cubed is 8 something cubed, and that's 2. 2 times 2 times 2 is 8. That means we can factor it. So we set up our 2 parentheses. Remember the first parentheses we drop off the cubes, and remember that 8 is 2 cubed. So that gives us c plus 2. We square the first term, c squared. We square the 2, which makes 4. For the middle term, you multiply those two together. C times 2 is 2c. Remember our signs? We look at the first sign, the second one's opposite. So plus changes to minus. Last one is always plus. That was factoring a sum of cubes. In the second parentheses, there's 3 terms. We can't pull anything out of all 3 of those terms. There's no GCF. So we look about setting up 2 parentheses. Do we have 2 numbers that multiply together to give us 4? Positive 4. That combine together to give us negative 4. You might be thinking 2 times 2 is 4 and 2 plus 2 is 4. But here it's a negative 4. So if we do negative 2 and negative 2, we should be able to factor it. Okay, so then again, look down here. Looks like no GCF and a difference of squares. C times c is c squared. 2 times 2 is 4. Difference of square signs, plus and minus. Looking at this last one, 3 terms again, nothing we can pull out. Do we have 2 terms, numbers that multiply together give us 4, that combine together give us negative 2? The answer is no, so we can't factor it, so it stays. Now everything is factored. We look to see on top and bottom if anything cancels. So c plus 2 reduces, c minus 2 reduces, c squared minus 2c plus 4 reduces. So it looks like all we have left is c minus 2 for our answer.